much. And let's welcome the first speaker, Richard.
Okay, so I'll be talking to you today about a landscape of AISafety that I worked on a couple of years ago. I'll address some of the actual content, but much of this will be about sort of the meta level of creating a landscape in the first place. So the motivation behind creating this landscape that I'm going to be talking about was to provide a scaffolding, a conceptual framework that will contextualize and orient people around the individual threads of AISafety research that we were going to be discussing at a particular conference, the Beneficial AI Conference, that actually also became known as the Asilomar Conference, from which the Asilomar principles came. But there was also a technical component to that conference, and this is what helped to structure and orient people there. But it also served as a sort of a reference point for the community because it had hundreds of references and interrelated the various concepts, hundreds of different concepts about safety and the related topics. So why is safety so important? It's important because as AI becomes more sophisticated, more general, more powerful, it can quite easily do things that we really wouldn't want it to do. And the canonical safety that the public seems to think about comes from Asimov, even though Asimov was arguing that his three laws, in fact, are not going to be sufficient in the future. So the whole series from Isaac Asimov is actually making the point that his three laws are not the answer. So in fact, we have a large field to address, and not just and not just some simple three laws with which we can tweak. So what's happening here? Is this so? I'm not controlling that. Okay, so we are aiming to tie together the near-term and long-term safety considerations and concerns and research threads. So this differentiation of near-term and long-term has sometimes created some little bit of a divide in the community because those who think about today's systems only think that potentially some of the considerations that are being raised are too sci-fi, as where those who are concerned about more powerful systems, which may come in a decade, may come in 100 years, but really we should be prepared for those when they do come, are being much more general in capabilities and provide many more kinds of challenges than we see in today's very narrow systems. But having a common conceptual framework for talking about these and sort of spectra on which to think about particular use cases can be very useful. We organize this into a tree format that helps to summarize, contextualize, and organize the various branches of the knowledge that we're talking about here. And different groups may have different conceptualizations of what these top-level core categories might be. And that's sort of one of the reasons why we're here today, to discuss these and to opine and to sort of make arguments for why we think certain types of structures in taxonomy make sense. So really, overall, we're working toward consensus in the creation process, and that's what we did with this Future of Life Institute landscape, and that's what we're doing today. So inevitably, there are multiple stages and multiple iteration on this kind of landscape. It's a very ongoing process, very collaborative process that involves many different formats of feedback, disagreements, where people will need to sort of deeply understand each other, which often is useful in sort of interpersonal context of just being able to speak over voice as opposed to just like long email threads. And inevitably there will be compromises on all sides in order to have some amount of consensus. And then later on I'll be talking about the benefits of the actual landscape creation process. So I'd like to note that the landscape as created has drawn heavily from research, technical agendas and research agendas from the Machine Intelligence Research Institute, both their Agent Foundations agenda and their machine learning technical agenda, which was more near term, as well as from Concrete Problems in AISafety, which was a seminal paper in this field, and also Future of Life Institute in preparation for actually our previous conference in 2015, which was simply calling the Puerto Rico conference, which was a pretty seminal conference in the field that laid a lot of the groundwork of people talking about AI safety and being open about, being concerned about AI safety. We had a document and an open letter that we put out then, which was research priorities for beneficial AI. And actually that's where a lot of the core of this taxonomy comes from. So specifically verification, validation, security, and control were part of the taxonomy of that original 2015 statement of research priorities. And we, in that paper that was actually published in AI magazine, that was authored by Stuart Russell and others. I don't know how this thing just keeps on advancing by itself, but here, I guess. So that gave some very concrete types of research threads that were quite relevant, quite needed, and making the case that there is actually a coherent field of AI safety that needs a lot more research, a lot more focus. And back then, in 2015, we did not have workshops like this in major AI conferences about AI safety. So, just at a high level, what we're talking about, first of all, I'll address the bottom four, actually. So, with verification, we're talking about going from a concrete technical specification to an implementation that we have a high degree of confidence in. So oftentimes this can be provable, oftentimes there are tight statistical bounds, and this can even address things like cyber-physical systems. Now, this does not mean we have 100% confidence in the implementation, but these are formal methods for giving us a very high degree of confidence. Validation is goal and specification alignment. This means that from the core of what it is that we actually desire and what exactly we means, what desire means, and even for that matter, what actually means, are all things that need a lot of discussion. But essentially going from what it is we're trying to actually get at to that formal technical specification in the first place is essentially what we mean by validation. Is that whole phase of specification, of technical specification. Now, others, as you'll see later, will separate out validation and specification as separate phases. Here we've chosen to sort of merge those as it is sort of a cycle that requires a lot of tight iteration. Security here refers not to IT security primarily, but to AI security. So these include things like adversarial examples, but they also include things like being able to manage biases, structured biases, be able to determine what sorts of data sources are permissible, and learn dynamically the types of permissions that one would be able to integrate with things like trust metrics, and be able to essentially ethically validate as well, relative to some original core or current core ethics. Control is relevant both in near-term and longer-term systems. Here we're talking about things like interpretability, transparency, monitoring, oversight, and control. So those were the 4 original core ones. Then we realized that foundations also really needs to be a core part of the tree here, one of the branches that are at the, tied to the root. So what we're talking about there are the things that are way too often overlooked in the machine learning community that are actually quite important for principled artificial intelligence. Things like theories of rational agency and of decision theory, being able to evaluate or iterate over types of counterfactuals in a very principled way, and be able to have provable types of theoretical bases, not only for our current algorithms that we're looking at in like deep learning and such, but also for entirely new types of artificial intelligence that might, for instance, be based on recursive self-improvement. So these are the cores here, and I'd like to note that the format of this landscape that was created was both of an interactive visualization and of paper. And so I actually authored this in a data structure that was then iterated on just dynamically to generate both the paper and that interactive landscape simultaneously. So I wouldn't have to update both versions twice. So the point there is that there's many different perspectives that are useful on some body of knowledge that's so complex as this. And if you can have even more than these sorts of 2 perspectives on it, then that would be quite useful. And I would just like to note that that's the URL, if you didn't see it before, of this thing, futureoflife.org/landscape, which I think I showed before, but just wanted to verify you've seen that. So as you see, there's quite a number of levels to this tree. These topics do get a little bit involved. Here's an example of some of the body of the paper version of this. So one thing that I want to highlight here are the connections between the nodes. So I didn't really point it out before. Let me quickly go back to show you. So yeah, I think it's a little bit washed out over here, but I think you can actually see it a little bit better here. So there's a primary tree structure, which are the blue lines and the nodes, but also very importantly, there's sort of a secondary structure, which are the sort of yellow-orange lines connecting the nodes. So although there is sort of a primary hierarchy, a taxonomy, really what we have and what we need is a graph of concepts that are related to each other in many complex ways. And here, in the interactive visualization, you have to actually sort of mouse over one of these lines, and it explains why there's a linkage between those nodes. In practice, in this visualization, it actually becomes quite complex to actually make sure you're over the correct little line, because there's so many of them, and they're so thin. But in the paper, we deal with this by simply putting them in the source node and rendering them as sentences saying C-section so-and-so for so-and-so reason, where the reason is specific to that linkage between the source and target nodes. And you can, of course, click the target node, which is the other section in that paper. So I find this to be a very helpful sort of mechanism for doing all these complex interrelationships between the different sections, or between the different concepts within the space. And I should note that the PDF table of contents is actually a quite useful tree as well in this sort of structure. So with respect to tying together nearer term and longer term concerns, I'd just like to highlight a handful of examples. So many of you are familiar with the need for monitoring of systems, transparency, interpretability. In the longer term, this will not really be scalable because humans are not scalable. The systems will be addressing extremely complex scenarios, and there'll just be too much content for humans, even crowdsourced humans, to be able to monitor. And so what you really need are new techniques for scalable oversight as these systems become more complex. And I would like to note that as we say longer term here, this does not mean 100 years from now. It doesn't specifically mean 10 years from now. This is simply a gradient. We're talking about, as systems become more complex, more advanced, more scalable, more general, and it's not a binary event that will get us there. It's much more of a spectrum. And so that's one of the reasons why we do actually need a unified field of AI safety. Today, when we talk about things like AI ethics or bias, fairness, really what we're talking about is value alignment. How we get the systems of today to be in line with the specific types of biases that we want them to have, as opposed to implicit ones that we don't want them to have, or for that matter, explicit ones that are entered in by bad actors in the data, or for that matter in the algorithms. Value alignment more generally in the longer term will need to be much more than simply fairness. But fairness and things like that get us to think about the types of concerns in a very specific, near-term, visualizable way that are very tangible to those who are not really familiar with the AGI concerns. Value alignment is much broader. People might think that we can have some simple rules as like safeguards that are essentially a combination of safety and maybe a little bit of ethics. But as mentioned before, Asimov's laws kind of are not really the thing. It's not going to get us there because there are very, very large loopholes in sets of simple laws. And those loopholes can be disastrous. They can be, so large as to drive, a truck through, metaphorically speaking. So really, we need a much more principled and sophisticated method of doing value alignment for those more general systems. When we talk about software verification today, oftentimes this sort of technique is applied to things like aerospace, avionics, or maybe military systems, or to possibly medical devices, things that are mission critical, and there can be a very high degree of investment going into something that does not iterate very much. But really, what we will be needing in the future to have more confidence in our systems is verifying the full stack of AI and machine learning. So, given that machine learning models are very dynamic, there are new challenges in software verification that that we just have very little knowledge of today. How do you verify a machine learning model? There are some early research theories on how to do this that are being explored, but this is very much an open field. Going to the next one, with things like contextual awareness, essentially common sense reasoning. In today's systems, we might have sort of very hard-coded methods of cost minimization or avoiding very specific types of negative side effects that one might think of in advance. But really, as we heard yesterday, we need much better ways of avoiding negative side effects. Many of the talks yesterday were addressing avoiding side effects in general that seemed unnecessary to those systems, to the goal. But it would be really nice to be able to differentiate negative side effects from positive side effects. So that's where more contextual awareness will come in. With things like the true AI security of tomorrow, we have things that are analogs today. Again, not in the IT security realm, but think more like abuse detection or fraud detection. Really, we're talking about statistical analyses. We're talking about being able to have models of what seems valid and what does not seem valid, and the chains of trust, the chains of reasoning, the chains of provenance and causality, for that matter, that need to be sort of deeply understood as, again, systems become more sophisticated. So I was hoping to do little drill downs into each of the trees. I don't think I have time. I'm not concluded very much yet. Okay, well, I'll just invite you to see some of these on the actual visualization and paper, which I'll be showing the URL of again. But I just want to note sort of the structure of this. So we have sort of a branch off the root and sort of sub-branches which sort of summarize what comes below them, or as well as kind of differentiates or splits what is coming off of the parent. Now this may seem sort of obvious to a lot of you, but I guess a lot of you also probably have not worked a lot with taxonomies either. But that's essentially the idea here. I should note that the colors on those represent the sources from which these things came. So in this case, the orange comes from Neary's Foundation's agenda, and white means that it was not part of some previous agenda. So similar idea here. I think purple would refer to. Oh yeah, that was the FLI research priorities paper. I just want to highlight validation here just briefly, because it is the largest branch of this taxonomy. It's taking nearly half of the graph here. So really, we're talking about things like avoiding reward hacking, value alignment, increasing contextual awareness, averting instrumental incentives. But again, this is going from what we want in general to the specification. And really, once you get to a really solid technical specification, the majority of work is done. Now, it doesn't mean that, things like verification and some of the more implementation types of aspects are easy, but things like value alignment are extremely difficult. And things like avoiding certain types of negative instrumental incentives of making sure that we don't fall into various traps posed by Goodhart's law are pretty challenging. So Goodhart's law is that once you create a metric that you strive toward, the dynamics of your activities and of the environment will essentially get corrupted because that metric is usually not a good proxy for what you actually want. It's very tough to create a good metric for what you actually want. And this crops up in a lot of different contexts, and there's many different ways. There's actually a really great paper on 4 different varieties of Goodhart's law that I think Mary put out a year or 2 ago. So, in the interest of time, I'll go briefly over these. So, just quickly, instrumental incentives come about when the system is of increasing power such that it's able to do things like spin up additional AWS instances or try to prevent its own shutdown. So this doesn't require some super intelligence to do this. If you simply have a robot that's supposed to be getting you coffee and it learns, it has a reward signal when it actually, when you say thumbs up when it gives you the coffee, it's going to figure out that if it's not able to give you the coffee, it's not going to get that reward signal. And so if in the middle of trying to get you the coffee, you try to push its off button, it's going to be able to figure out that if it stops you from pushing that off button, it can do its job better. It might actually be able to give you the coffee. So this is the sort of thing that we want to prevent. With something like value alignment, again, it's a very large and complex space that we should not at all feel confident in there being simple answers to. I mean, many people think that a simple rule or a single set of simple rules might be able to do the trick, but really that is way too simplistic of kind of thinking that can lead to disaster. Security, again, handling improper external behavior, things like privilege biases. Control and oversight are very important. I'm sure you'll hear today about monitoring quite a bit. I do want to highlight that that the concepts of deference and of humility, are important here. So I was told that I had very little time, so I'll kind of skip ahead to some of the nature of getting to more consensus. So though I was the primary author of this, there was feedback from a wide variety of people with knowledge of the field. Things like adding the top-level foundations branch was a great suggestion we got from Miri. But there were other suggestions that the individuals just did not agree on. And things like the relative hierarchy of corrigibility, computational deference, computational humility, and utility indifference. Some people have the perspective that certain of them are more encompassing than others, or that certain of them imply the others. And really, this is the level at which there's a lot of discussion, where the ways of thinking about the world, the ways of thinking about how things will interact or what is more primary than other things actually cause a lot of these disagreements. And so what I would say is that we can't actually expect a full consensus. We would ask people to make arguments for why they believe that some node should, let's say, be above versus below some other node. but people sometimes have different definitions of things, and we have to make compromises along the way. Now, trying to get to a more common definition of things is important, and it's sort of something that we should sort of actively strive toward, and that's one of the things that we're working toward today. So, just very briefly, the benefits of creating this type of landscape are many. So for one thing, it helps us to find unknown unknowns. It helps us to uncover our own blind spots and also those of people we're interacting with. Finding divergent perspectives and helping us to address some of those differences by figuring out where we need to do more research or where we need to discuss things more within the community. It also helps to orient people who are new to the field. And it also helps to summarize, helps to save people time. And it also provides a relevant sort of GPS or map to relevant research to a given type of subthread. Okay, so thank you all. I invite you to check out the actual landscape, and that is the URL.